Okay, the next video I'm going to show is sort of coming from the other direction, writing formulas from names. Okay, now this is, I would say, a little bit easier, and I think most people would agree. So, similarly to before, the first question we always have to ask ourselves is this ionic or covalent? Okay, and the way you determine this is actually a lot easier. You don't have to look at your periodic table. You don't have to determine if it's a metal or a non-metal. All you have to do is look at the name. If you see Greek prefixes, it's going to be covalent. If you don't see Greek prefixes, it's ionic. That's step one. That's all you need to know. Greek prefixes, covalent. No Greek prefixes, ionic. So if you see the Greek prefixes, let's talk about how you actually name this. So the first thing you have to know is your Greek prefixes list. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Memorize these. Important to know. So if you see these, you know it's going to be covalent. You just write the elements in the order that they appear. So for example, if you see silicon tetrabromide, first thing you should notice, tetra, Greek prefix, we know we're looking at a covalent compound. So we look for both prefixes. Well, I don't see anything here, so that must mean there's one. So silicon is Si, so I just write that. And tetra is 4, so 4 bromines, Br4. Just like that. Careful not to accidentally put the 4 in here. You're not going to write silicon tetra bromide. That would be wrong. Make sure you write silicon with 4 bromines. Okay, let's just do another quick example. If you see dinitrogen, tetrachloride. Again, the first thing you should notice is your Greek prefixes, di and tetra. So we simply write our formula from that. Di is 2, so dinitrogen is N2. Tetra is 4, so this is Cl4. And this is complete. What's important to note is that when we're writing covalent compounds like this, you don't simplify it down to its simplest form. If you were doing ionics and you ended up with something like Mg2O2, you would simplify that down to MgO. But with covalent, it's important to leave it as it's written. So N2Cl4. Naming covalents, or writing formulas covalents, very straightforward. So if you don't see any prefixes, you know you're dealing with ionic. Okay? With ionic, there's pretty much one general rule to sum up everything. So, when writing ionic formulas, most important thing you can do, make it a two-step process. I see so many students just trying to take their first stab at it and they end up getting it wrong. Just make it 2 steps. The first step, write the ions involved with charges. Okay. Step 2, what I call the Crisscross Rule, in which you're actually going to write what the formula is. Okay, and we'll get to that in just a minute. So let's run through some examples. By the way, this works whether you have polyatomic ions, whether you have transition metals, whether you have the regular, which are binary ionic, or what I call like the normal covalent. So let's start. Let's say you see silver phosphide. Okay, silver phosphide. Do I see any prefixes? No, I don't. Ionic. So what I'm going to do is write my ions involved. Silver is Ag. What's the charge on a silver ion? Silver is part of my 3-2-1 rule. Silver always has a charge of +1, which I write as a plus. Phosphide is phosphorus. which has a charge of 3 minus. At this point, I'm going to apply my crisscross rule. What I mean by that is the number that's represented up here is going to go down there. The number that's represented up here is going to go down here. So the plus means plus 1. So we assume that's a 1 and it goes down here. This 3 goes down here. What I end up with is Ag3P. So we don't write the 1 there, but there is a 1 there. So this would be silver phosphide. Let's do another example. Iron 2 oxide. We've actually worked with this one in the last video, but let's talk about writing a formula. So, first step, is this ionic or covalent? Do we see any prefixes? No, we don't. Ionic. Now I'm going to write my ions involved. So iron is Fe. I don't know what Fe is always, but I do know that this particular iron has a charge of 2+. Remember, that is what the Roman numeral means. It doesn't mean there's 2 irons. Another common mistake I see, people see iron 2 oxide, they say, oh, iron 2 oxide. That's wrong. The charge is indicated by the Roman numerals. So, I have an iron with a 2+, and then I have an oxide. Oxygen is always the same thing every time, O2-. So at this point, you can just recognize that it's going to be a 1-to-1 relationship, because it's 2+ and 2-. Or you can do your crisscross rule, but then you have to consider one more step. So by the crisscross rule, 2 goes down here, 2 goes down here, Fe2O2. But this is incorrect for an ionic compound because we're always looking for the simplest ratio of elements. So not Fe2O2, we're going to simplify that down and just write FeO. So this is going to be iron 2 oxide. Okay, another example. Let's say we have lead for acetate. Is this ionic or covalent? Ionic. I don't see any prefixes. So we're going to write the ions involved. Lead is Pb. Do I know what lead is? Not always, but I do know what this lead is. It's a lead 4. So that means Pb4+. Acetate is one of your polyatomic ions. Make sure you memorize those. C2H3O2 with a charge of minus. At this point, we just do our crisscross rule. So my 4 is going to go down here. My 1 is going to go down there. What I end up with is this, Pb. Now, if I want to write 4 acetates, I need to use parentheses. Here's what it would look like if I didn't. If I just put my C2H3O2 4, this looks like 24 oxygens. That's not right. I'm showing you that I have 4 acetates, so I need to use parentheses around the acetate to show that. So it's Pb C2H3O2 parentheses 4. Let's see. What if you have, let me spell that correctly. Hydrogen monoxide. First step, is this ionic or covalent? Di, mono, covalent. So you just name it using Greek prefixes. Dihydrogen means 2 hydrogens, H2. Monoxide means 1 oxide, H2O, water, dihydrogen monoxide. Let's do one more quick example. Let's see. Okay, how about aluminum? Phosphate. Not phosphate. Carbonate. Is this ionic or covalent? I don't see any prefixes. It's ionic. So I write my ions involved. Aluminum is Al with a charge of 3+, always. Carbonate, polyatomic ion, CO3, 2-. Crisscross rule. 3 goes down here. 2 goes down here. What I end up with is Al2. But I have 3 carbonates, so I put it in parentheses. CO3, close parentheses, 3. It's really important that you don't include any charges in any of these compounds. I see way too often someone will put something like Pb C2H3O2 minus 4. By being in an ionic compound, this 4, or this negative, gets canceled out because we have 4 of them with the lead 4. So make sure you don't include the charge there. Okay, so if you're looking at this from chemistry, make sure you check out my Edline. We have all these worksheets up there. Physical science, we have a lot of worksheets through this, and that is how we write formulas.